Welcome everyone, and thanks for joining us today. Let's start by familiarizing yourself with the webinar tool. Take a look around for the chat and tell us where you're located. And I just have a few housekeeping items, things to be aware of. We have some upcoming known dates for future events. We have the IIoT World's ICS Cybersecurity Day 2021 is coming on October the 6th. Registration is open now. And we're taking questions at the conclusion of this session, so please post your questions to the chat. This track will run for 55 minutes. We'll have you out of here on time. And I'd like to say it wouldn't be possible to run this virtual conference without the help of our sponsors. So thank you to our sponsors for this session, Hitachi Vantara and Eurotech. Now, before we get into it, I'd like to tell you a little bit about IIoT World. IIoT World is the leading authority on industrial IT. IIoT World is a digital media outlet bringing you the latest industrial things, virtual conferences and content to the global community. That's 279,000 decision makers and influencers like you. IIoT World focuses on delivering daily insights on the IIoT, artificial intelligence, augmented reality, predictive analysis, digital disruption, autonomous cars, cybersecurity, machine learning, and smart cities. Well, that's it. With housekeeping out of the way, I'd like to introduce our topic and speakers for this session. The topic, we're focusing on the changing EV infrastructure in 2021 and beyond. Our goal of this session is to understand the trends in EV adoption and the implications for infrastructure. As you know, electric cars are coming fast, and you know, they say that there's 1% of the vehicles on the road are electric these days, and you just imagine when it's 100. You know, General Motors has already announced they plan to offer exclusively electric vehicles by 2035. They're going to be ending production of its diesel and gas-powered engines. Mercedes and Ford both say they're going all electric by 2030. And you know, although even Toyota, although it's dragging its heels, everyone's getting on board. So it's coming fast. Let's look at what it means for infrastructure. I have our panelists. I'm delighted and honored to introduce a great set of panelists for today's session. We have Rick Nicholson, the Global Digital Business Development Manager for Hitachi ABB Power Grids. We have Scott Shepard, the Principal Research Analyst for Fleet Decarbonization, and Dr. Siri Varidan, the Global Director of Strategic Solutions for Asset Management at Hitachi ABB Power Grids. So I'm your moderator. My name is Graham Bennett. I'm a consultant, an automobile journalist, and a reviewer. I've had a keen interest in electric vehicles ever since I reviewed the General Motors EV1 back in the 1990s. So greetings to all our panelists, and let's kick it off. I'd actually like you each to tell our audience a little bit more about what you do in your role. Can we start with you, Rick?
Yeah, sure. Thanks, Graham. And hi, everybody. Thanks for joining. I'm part of the digital team here at Hitachi ABB Power Grids. And my role is quite simply to focus on growing our digital business globally. One of those high growth segments that we're focused on is EV charging. So it's a great fit to today's topic.
Thank you very much. Let's move on to you, Scott.
Thanks, Graham. Yeah, and thanks everybody for joining. I'm with Guidehouse, specifically Guidehouse Insights. I've been doing market research primarily, but also consulting in the EV space for the last 10 years. And as an analyst with Guidehouse Insights, we produce a lot of material and forecasts on the EV market and the EV charging market as well. So very happy to be here and share my insights.
Thank you, Scott. And Dr. Siri Varidan, let's have a word from you.
Absolutely. Thank you. This is a pleasure to be here. Thank you, and welcome to everybody. As Global Director for Strategic Asset Management Solutions, I mainly work with utility customers to understand their business issues and then stitch together solutions that leverage one or more products or solutions from our portfolio of solutions, right? Specifically for asset management, this includes EAM, which is our enterprise asset management solution, APM, which is our asset performance management solution, and FSM, which is our field services management solution. Asset management as such looks at things from a cradle to grave in terms of commissioning, planning, commissioning, operations, and the whole life cycle. So I'm very happy to be here. This has a huge impact on the things that I do. So glad to be here.
Excellent. Just very briefly, we're going to go in questions for each person, and we have 3 minutes. So if you finish up in less than 3 minutes, don't worry about it. So we'll fill in the gaps. But let's start off continuing on with what you just said, Siri. Could you explain for us at a high level the scope and magnitude of the impact of EV adoption from a utility perspective?
Sure, absolutely. From a utility perspective, the things to look at are essentially electric vehicles are an increase in load, okay? And anytime you have an increase in load, that means an electric utility has to plan for it. Now, what makes this a problem of sizable magnitude and concern for the electric utilities is that the loads here are coincident, right? So when people come back from work after a busy day of work, they come back home and they plug in at, say 8 o'clock or 9 o'clock. So this makes it a very coincident load, which means that the demand is high at that particular time. It also comes at a time when the generation from solar resources and wind resources are actually dying down at the end of the day. So this makes for a difficult sort of situation where supply and demand can't be met. There's a question of timing because of the coincidence of the load, and that makes this thing more difficult. From a magnitude perspective, the preliminary studies show that a modest 15% of increase in load can cause problems. And we'll talk in a little bit what those problems specifically are and what the solutions could be for these problems. The overall impact is IEA predicts that there will be 30 million EVs by 2030. And if you take a state like California, that basically means by 2045, 26 million cars, 900 medium heavy-duty trucks, and 17,000 heavy-duty trucks and 900,000 medium-duty trucks need to be electric. To give you a sense of perspective, in 2021, there are just 14.8 million registered vehicles. So there's a huge growth, we need to be prepared for that. So that's the magnitude of the problem that we're talking about.
Absolutely. Well, thank you very much for that. Scott, let's talk a little bit about the developments in EV technologies that you think are most impactful in shaping the charging infrastructure systems. Scott?
Yeah, certainly. Thanks. Yeah. So, we've been monitoring the market for years now. And in the last 5 years or so, one of the biggest developments for charging infrastructure has been integrating batteries into charging infrastructure systems. And that's gone so far as to enable mobile charging systems, but also to integrate the battery directly in the charging unit. And there are a lot of benefits to doing so for site hosts. One is to offset some of the grid upgrade costs that might be required for certain types of charging stations, specifically DC fast charging stations. There's also benefits for power management and ensuring that energy costs remain low through batteries. To date, it's been a fairly slight market share that has adopted batteries directly within the charging units, but the continued decline of batteries, which I believe everybody is fairly familiar with, is pushing more and more charging equipment suppliers to prepare to integrate EV batteries in their charging units at a much higher rate. So we are looking at that becoming quite frequent by 2025 with the drop in battery prices. The other element to batteries that is particularly promising is continued development of more interoperable battery systems between vehicles and offtake markets. So as vehicles are becoming more standardized, the battery systems are beginning to look a little more similar to each other among EV producers, and that is opening up opportunities to swap batteries from one use to the next. And in the future, we anticipate this market is going to be quite large and will help supplement battery demands for EV charging, as well as a suite of other grid service needs. The last one I want to speak to, and there are many more, is on just the growing availability of heavy commercial vehicles, or electric heavy commercial vehicles. The class of heavy commercial vehicles is highly diverse, and therefore there are just a diverse variety of charging solutions, and that variety in and of itself is creating a very competitive market for future charging solutions, and I'll speak more to that going forward.
Well, you're absolutely right about the impact of batteries in reducing the peak power costs at the peak times, you know, so yeah, absolutely. Rick, let's talk a little bit about the role of digitalization, you know, how will it play into the EV charging infrastructure, analytics and all of that. What do you think of that, Rick?
Well, great question, Graham, because, you know, if I look at, you know, where we are today and some of the goals that we're seeing set around EV adoption, you've got a huge issue around scalability. I mean, you mentioned when we opened the session that the average was about 1% of vehicles are EVs currently. I mean, I've seen in certain countries or regions, you know, that we're maybe at 4%, but we're certainly, you know, I've never seen anything that would suggest that we're above the single digits, right? And, you know, you can manage to charge that kind of level of penetration with existing infrastructure. You know, you can get by. No one's saying you can't do that. Let's take the example of the recent announcement in the US by the Biden administration that we're setting a goal of 50% of electric vehicles purchased by 2030. Now, that's a big challenge, and it's a challenge around how do you scale to that level. It becomes virtually impossible to scale to that level that quickly without digitalization, right? So, I mean, you need to have secure connectivity to the charging facilities so that you can collect data from them, so that you can monitor them, so that you can send control signals back to them, because you need to manage all of that charging. You need to manage how much each station is allowed to charge at what time. You know, you need to take all that data and be able to forecast what the charging load is going to be. I mean, Siri mentioned that, you know, this to a utility, this is a big shift in load. It's an increase, and it might be hitting at a certain time. So, you know, data is kind of the foundation that's going to enable you to scale that much and that quickly.
Absolutely. Absolutely. Well, you know, and of course, it's not just the consumer market. There's the fleets and there's the whole industrial infrastructure that's going on as well. And that's a huge component when you think of all the transportation industry that is going to be shifting over as well. So let's talk a little bit more, each of us here, let's talk a little bit more about infrastructure growth and forecasting and energy use, you know, on the industrial side. Rick, for example, how can microgrids and virtual power plants be used to minimize EV charging costs and provide greater value? Continuing on with your idea.
Sure, yeah. Well, I mean, if what you do is you look at some of these large fleet charging facilities that are being planned, you know, and whether it's in the public transit sector like electric buses, or whether it's in the private sector and you've got, fleets of, let's say, delivery vehicles, that's where you're going to see a particular, let's say, pinch point as far as the grid being able to support those facilities. I mean, we're talking about adding multi-megawatt loads to, a distribution network that wasn't planned to support that. And once again, I think what I'd get back to is, yes, you can kind of take a brute force approach and build new substations and new feeders to serve that load, but it's not a very efficient way of doing it. It takes a long time, it takes a lot of money, and you end up having to overbuild the infrastructure, the power infrastructure to support that. So really, one of the ways around that problem is to treat these kind of fleet charging facilities as microgrids. And you can start without it being, let's say, an extensive multi-asset microgrid, but you just start with the idea that what you want to do is incorporate, as Scott mentioned, battery energy storage into that fleet charging facility.
Mm-hmm.
You can start looking at is how can, through analytics and optimization software, how can you reduce what you're paying for grid power by utilizing the battery capability? I think most people know that what you pay for power has at least two components. It's got an energy charge, so let's say the volume of energy that you're using, and it's got a demand charge. What are you paying for peak power? And a microgrid approach can help you manage both your energy charge and your peak demand charge. We've done some modeling. So let's say that you have a 4 megawatt charging facility. By combining some smart optimization with some local battery storage, you could probably save somewhere on the order of $100,000 to $200,000 per year in what you pay for power by taking that type of approach. And that's not even going further, where you might add, for instance, solar resources to that local microgrid, which could further improve your capabilities to manage the the costs associated with charging.
Interesting. Yes. Now, you mentioned what Scott was talking about. Now, Scott, Guidehouse provides research and modeling capabilities to forecast vehicle adoption and infrastructure growth and energy use and things like that. So let's talk about the heavy commercial fleets. How are they approaching electrification?
Yeah, certainly. The heavy fleet market is one of the most interesting markets. As I said earlier, it's highly diverse. And so you get a lot of variation in terms of the adoption curves for fleets. A couple factors that are important to note here is, who the stakeholders are of the fleet. Typically, those fleets that are highly sensitive to corporate interests or either owned by a corporation are going to be the quickest to adopt. And those fleets that are smaller and maybe contracting are going to be much further from that sensitivity point with corporations. So ultimately, there's a lot of variation in terms of adoption. And a lot of ways in which fleets are looking to adopt in the form of infrastructure, in that there's such a variety of solutions that it's actually a bit of an issue for the fleet. This is an incredibly sophisticated engineering problem for them. The charging solution not only has to fit within certain grid capacities, but it also has to fit within certain spatial constraints. For the fleet depot, certain egress, ingress engineering problems are also present. So really, this is a massive transformation for a lot of fleets. Ultimately, the early market has shown a lot of preference for using behind the meter or customer side of the meter solutions to help transition the initial fleet. At some point, there is likely going to have to be a mix of both solutions coming from the grid and from the consumer side of the meter. So we don't expect fleets are going to go away from investing in generation and storage side assets as utilities catch up with their own transportation electrification programs designed for fleets. But ultimately, there are a lot of issues, and so it's not only an engineering problem for fleets, but it's also one of trying to decide what is the right technology for them, whether it's a pantograph solution, whether it's a L3 AC charging solution, whether it's a DC fast charging solution. There's just so much development here. And largely there's a lot of interest from fleets for a variety of reasons, but it's going to be a transition that takes a long time and creates a lot of opportunity looking forward. But overall, I'd say, to summarize, that fleets are earnest, but they're also in a pretty prickly situation when it comes to engineering.
Mm-hmm. Interesting. Now, as we've talked about here, Siri, EV adoption, in many ways, is essentially a load management problem from a utility perspective. So what existing technologies can be leveraged to solve this as a demand side management sort of problem?
Sure, this is a very interesting question, and I'll quickly recall when in the early 2000s I was doing M&V studies for CEC, which was this the California Energy Commission, and this was looking at how demand could be controlled, right? And at that time it was more of a supply problem because the market was working its way out in the early 2000s, and people were looking at what ways to adjust load, right? And there were a bunch of technologies at that point in time, which range all the way from sending out a signal, and that signal would basically do load curtailment at the various loads. Then there was all of the back end, which is how much load was actually reduced, and how would you pay for it, and there were all of these incentive schemes, right? Which involved TOU and real-time metering and so on, right? The objective there was fairly simple, which was, how do you basically manage the load, right?
Mm-hmm.
In this case, the problem is much, much worse. I'll tell you why, because it's not only the load that you need to manage, but it's also the supply. The reason is because one of the fundamental goals of EV adoption is so that we can get towards a greener future, right? Where we're basically having, lesser dependence on fossil-based fuels. So adding more fossil-based fuels to solve the supply problem is not the solution. You've got to come up with other ways to basically deal with the supply side. And here the load is increasing by a lot. In the early 2000s, it was a supply problem and the load was not much of a problem. Here you have both. You have the load problem becoming much, much worse, and you also have the supply problem where you have additional constraints because you cannot leverage the conventional forms of energy that we've been used to in the past, right? So now that means all the extra demand has to be met by either wind, solar, behind the meter solar, battery energy storage, hydro, pump storage, or nuclear. And the last one there, nuclear, seems to be like a taboo word now. Of course, things are changing with investments that Bill Gates and his companies have been making. Terawatt, for example, making SMR type reactors, but that's another story. That leads to the discussion of how to manage the supply side. If you look at it from the load side, right, the key things that questions that need to be answered are such. Now, how do we shift the load, right? So, for example, that is the fundamental problem in load management. Instead of having a peak, a spike between 8 and 9 p.m., can you split that load evenly and distribute it across the hours between 8 and say next day morning 5 o'clock or 6 o'clock when people are again getting up and ready and going to work, right? So if you can spread that out, that's definitely a good thing from a utility management perspective. And the other thing also is, and Rick mentioned this, which is, the need for larger, wires, because, the need for demand. The demand is higher up. There are two parts, energy and demand. In this case, both need to be satisfied. But primarily, from a demand perspective, if you have more local resources, right? So for example, if you can locate your energy storage solutions closer to the neighborhoods where these large electric vehicles demand is going to happen, that is something that we should certainly look for and encourage. The other incentives are in terms of what can you do to influence customer behavior, right? So maybe they don't say that we all must charge when we come back home, but they say, you know what, we charge when we are at work. So you need to have the infrastructure at work. So for example, wherever they park in a parking garage downtown or something, you need to have the infrastructure there. But even that means that there is an impact on the utility. The utility then has to plan to be able to supply the downtown area, rather than the residential area. So there is a lot of stuff in terms of, from a utilities perspective. You need to identify weak and strong buses in the grid. Why? Because an increase in load like this will lead to voltage drops, and when you have voltage drops in the distribution system, that means now your losses in the system have increased. So you've got to solve one problem and you've created another problem.
Well, this brings up a very interesting situation. A question of the charging infrastructure itself. The question is, how will the charging infrastructure need to change to support the introduction of internal combustion engine bans and those kind of changes, which are not 9 years away, as you were talking about, as we were saying earlier. So let's put that question to you, Scott. Let's look into the charging infrastructure question, the power delivery issues related to that. What are your thoughts on the roles of how the charging infrastructure will need to change?
Yeah, certainly. I mean, when we're talking about going from 1% to 100%, there is a lot of consumers who are not yet there, who are going to need a solution that works for them. And right now, it's well known that EVs work really well for the consumers and the fleets who own their own parking infrastructure and can deploy their own solutions, invest in their solutions, hold on to them for a while to get that return on investment. Outside of those customer classes, it's a really tough sell. And there are some solutions being deployed now which can help get there. It's important in discussing this to actually kind of shift from the fleet market and talk about the light duty vehicle market or the consumer market, because developments there have the effect of following on to the fleet market 5 to 10 years later. And so when we're looking at ICE bans coming into an effect between as early as 2025 but all the way to 2040 and 2045, we're talking about needing solutions that are orders of magnitude faster than even 350 kilowatt chargers that are being deployed in the market today. It is true that somebody who owns a vehicle and parks it on the street could theoretically supplement their charging from a workplace, a destination charge point, level 2 charger, as well as a fast charger. But that is a particularly savvy customer or savvy EV driver, and we can't expect all EV drivers are going to be on the same page when it comes to that. So what we see as kind of being necessary to get to ICE bans is, as I said, orders of magnitude greater than the 350 kW charging solution. And what we see happening in China is a potential solution for that, and that is the development of battery swap systems. Now, those swap systems are pretty far away from being commercially scalable, but when it comes to a lot of the issues with with EV charging infrastructure, from the grid perspective, from deployment perspectives, from consumer perspectives, there's a lot of potential there, a lot of challenges, but a lot of promise. So we see that trend as being very important to and an important enabler for ICE bans. And the development of battery swap systems is only in China right now, but it's migrating to Europe. It's sort of emerging in North America again. And we expect some interesting developments in this space looking forward. So yeah. I'd say that potential to spill over into the fleet market as well.
Yeah, thank you. Siri, I'd like to ask you a question about the role of integrated resource planning, IRP, in dealing with EV adoption impacts on the grid. Could we talk a little bit more about the solutions that you think utilities should pursue? Siri?
Yes, absolutely, absolutely. So one thing I do want to mention before I answer this question related to ERP, the fundamental problem that we're trying to solve is EV loads, the increase, have detrimental effects on power systems if they're not planned properly. Why? Because of the increased peak demand, reduced reserve margins, voltage instability, and poor reliability. Right. So these are the constraints that under which utilities need to do planning now. Right. So these are the things that need to be included in what is an old term. IRP is not a new concept. It has existed for quite some time. And basically, it's a public process in which planners work together with other interested parties to identify and prepare energy options that serve the highest possible public good, right? So IRP has been around for a while. I see the re-emergence of IRP as a solution now, because not only do you have to deal with the supply side issues, because you have, as I mentioned earlier, a limited set of resources that are actually connected to the diurnal cycle, right? That's one. The other is the load is also doing the same thing. It's connected to, again, consumer energy patterns, right? Usage patterns. So unless you balance these two and deploy technology in the right way, right, which is what Rick talked about, which is smart charging, right? So we need to have a consortium where people work together to basically solve these issues, right? So I certainly envision that smart charging is going to be a really big part of this whole solution, because that's the only way that you're going to be able to flatten out that load and be able to get away with minimum sort of investments in the infrastructure, the grid infrastructure, in order to be able to support this load. Because if not, it's going to be a huge cost. And we have to bear the cost.
Let me stop you there. And Rick, let me ask you about what Siri was just talking about. We've been kind of circling around the notion that there are these big risks. Let's talk a little bit about how digital solutions can be used to minimize these risks. How can we mitigate them?
Okay. Well, I mean, I guess just following on from what Siri was mentioning, there's kind of two big risks from let's say a utility or infrastructure perspective, right? One is called grid hosting capacity, which in layman's terms is basically, are the wires big enough, right? Can we move enough power from a generation source to the load, which is the charging stations, effectively, right? So you've got that risk you have to manage. And the second one, which we don't really talk about as much, but it's going to become, I think, more and more of a risk that we will hear about, and that's power quality. In other words, by introducing, once again, getting back to some of these very large charging facilities for fleets, you could very well introduce, noise onto the distribution network, harmonics, that impacts the power quality of other consumers that are using grid power, whether it's the homes that are on the same circuit, or maybe it's a commercial office building or a store or whatever. So you have to kind of manage both of those risks. And once again, it comes down to, do you have the adequate capability to monitor all of the charging infrastructure in real time? Are you collecting the right data so that, once again, you can kind of optimize all of that charging in a way that mitigates those risks? And what we're not envisioning here is the old style, an operator sitting in a control center looking at screens and making decisions. Once again, that's not a scalable way of addressing this. This has to be a highly autonomous system that's effectively self-managing. Obviously, yes, there's the ability for a human operator to intervene at a certain point if that's needed, but by and large, this has to be a self-managing, self-healing system that kind of runs itself based on whatever the algorithms, the AI that's built into it to to mitigate those risks. And if you'll allow me to also just go off script a little bit here, I've seen some of the Q&A chat going on, and there's been a number of people that have kind of asked about what about the opportunities, and I think you do need to think about how do you balance risk with opportunity in that type of scenario. And I'll just throw out one quick example, and that is that when you have that level of digitalization, it presents the opportunity to do something with spare battery capacity. And whether you're talking about a large stationary battery energy storage system that's part of a fleet charging facility, or you're talking about the ability to aggregate batteries in vehicles into what we would call a virtual power plant. When you have that capability, then you can start to do other things with it, like potentially bid it into energy markets, because it's spare capacity that you can do something else with. So you can kind of stack value on that capability. So there are two sides to it. There's the risk side and there's the opportunity side.
Absolutely. Now, you raised the fact that yes, we're all getting lots of questions on the chat, and we'll be leaving some time at the end of the session to talk about those chat topics. But one of the big topics that's emerging there is something that I'd like each of us to talk about in 2 minutes or less each, and that is the idea of this. The emerging infrastructure dealing, as you said, where with demand and reliability issues. Let's talk a little bit about the place for renewables, and if we're just burning coal to create electric power, we're not getting anywhere. So let's talk a little bit about this. Maybe let's start with Scott and I'll ask you, Scott, what impact do grid reliability concerns have on the infrastructure system?
Yeah, certainly. Well, there are a couple different ways the concerns play out, and I wouldn't really tie the concerns to renewables as much as I would to climate-related impacts. Those are the areas that fleets are most concerned about, and consumers. And looking ahead, what is happening is that a lot of fleets are turning to microgrid solutions and behind the meter solutions, and microgrids are kind of the enabling solution behind that. The question is basically, how are you going to finance that, and how is it going to make economic sense? Because historically there's been some hesitation around the duplication of grid power with behind the meter power. And so digitalization is incredibly important here, because you can maximize those assets behind the meter for certain capacity markets, as Rick discussed earlier. So basically teeing up all these assets and making sure that they are optimized not only for reliability issues, but also for grid service markets is a big component in making the grid more distributed and more reliable. And that's not just affecting fleets, that's affecting customers.
Thank you. Let's return to you, Rick. You were talking about renewables. How can renewables be used to support EV charging?
Well, I mean, I think there's kind of two big areas. One is if you're looking at power that's delivered through the grid, a grid charging entity, whether it's a fleet operator or whoever, could sign a contract with an energy provider to ensure that they're getting 100% renewable energy from, let's say, wind farms or whatever. I mean, we've seen that already. I mean, a lot of the data center owner operators have been on the forefront of signing those types of agreements. So you've seen things, in the press about, Google or Apple or Amazon or whoever, guaranteeing that their data centers are using 100% renewable energy. That's typically done through some sort of power purchase agreement with somebody that's basically going to guarantee that, that the power they're using is effectively 100% renewable, even though they're getting it through the grid. So there is that aspect to it. And then, as Scott mentioned, there's the local microgrid aspect of it. And once again, there is definitely a history of using microgrids to increase the amount of renewable energy that a facility is using. This wasn't kind of invented by EV charging. We've done a lot of projects for like remote mining facilities that used to run on 100% diesel, right? They just have diesel generators. It doesn't even have to be a mine. It could be any remote community that's not either not grid connected or weakly grid connected. And by adding renewables, typically solar, you can reduce the dependence on fossil fuels by reducing the dependence on diesel generation sets locally. So you can take that kind of tried and true concept, just use it for a large EV charging facility where you're reducing any potential dependence on fossil generation, whether it's through the grid or locally, by adding more and more renewable capacity through the microgrid. So you've kind of got both of those.
Yeah, excellent. I have to cut you off there. We're running a little bit behind time. Siri, in just 1 minute, if you can you speculate on the operations and management and capital expenditure needs of the future, how that's likely to play out?
Yes, since I have just a minute, I will just say increase in loads, okay? Then there's going to be the need for, reliability. All this basically means that, you need to have a system that is more, in better health. You need to make sure that you have people, that the O&M expenses will increase, because now you need to make sure that, there's more monitoring, there's more diagnostics, there's more capability to be able to know the health of your system and to be able to know the associated risks of failure. There's also going to be, a bow wave, which essentially means that, you need to start looking at replacement of a lot of these assets, because, there is at any point in time going to be a mixture of vintages of all of these assets, right? So there is going to be a large, need for replacement of many of the older assets. So I see increases in CapEx and increases in OpEx as a result of, these activities.
Yes.
They can be managed, and we'll talk about, solutions, later, but, if you don't do anything, that's where we're headed.
That's right. Well, it's time for some final comments, I guess. One of the things that I'd like to get each of your opinions on, just in 1 minute each, we've talked about the fact that EVs account for a small percentage of vehicles on the road. Is there an industry segment that you see lagging behind the curve during this changeover? Let's have each of you, starting with Rick, in 1 minute. Is there an industry segment that you see lagging behind?
Well, I mean, from my perspective, I'm going to preface this by saying that this is not based on a valid market research study. This is just kind of my observations. But in basically the general population, not the high-end car buyers, not the fleet operators, not the long-distance trucking, but just your average person that buys and drives a car. We don't have enough electric vehicle offerings that are affordable for that segment of car buyers, and I think that's something we really have to also focus effort on if we're going to achieve the goals that we've set out.
Absolutely. And I mean, I look at it, I'm amazed that I see so few charging stations as an incentive to go to a brick and mortar operation. That seems like a great opportunity that is, not being done as much as I'd imagined. Well, what are your thoughts on this, Scott?
Yeah, actually, Rick brings up a good point, one that I hadn't actually thought of addressing, but I agree entirely with him that that's the major area that's needed for development. But outside of that area, I'd say at least on the fleets component of it, I wouldn't actually call it lagging because there's a lot of energy there. Like with long haul, it's definitely going to be the hardest component to electrify, but I wouldn't call it lagging because there's just so much investment going in to that solution. Where I'd say there's some lag is in the in vehicles designed for construction equipment, mining, etc. They have large auxiliary loads that need to be planned for, a lot of dynamic routes. So there are various segments throughout the fleet market that are difficult to electrify. There are some opportunities. There are a lot of challenges, but there's not as much development there as there are in other fleet segments.
Thank you. Siri, in 1 minute, some closing remarks from you.
Yes, I will speak to this from the utility side of the business, right? One thing is that, I think there is a severe lack in the amount of integrated resource planning sort of tools. Because even today, people study the transmission system and they study the distribution system separately. To put the whole thing together in one model and study the effect from end to end, that is something that still does not happen on the utility side. And that would be very, very nice to have those sorts of tools. The other thing is, much like how AMI was introduced a few years ago, and now utilities have a better view into the customer's energy usage patterns and things like that. The other thing that needs to happen is utilities need to spend more in terms of being able to have a clear view of their assets, to know exactly what is the health of your assets, to know exactly, when an asset is going to fail, and to be able to simulate those scenarios, on their side, to be able to plan for something like this. So I think, the tools are there, but the adoption of those tools is typically tied to the business case of digitalization in utilities, and that is lagging in my that needs to come up to speed.
Thank you very much for that. So we have a lot of great questions from the audience. I'd like to throw a few of these out of there, and anyone who wants to answer them, if I point at you, that's great. And if not, you can raise your hand and have a shot at it. I'd like to start with a question from Rajiv, who asks, electrical charging facilities have largely been free till now. Rajiv says they have to move to pay per use. This will provide utilities a return on their infrastructure investment. When do you think that that's likely to start to happen? And let's ask you, Scott.
Yeah, well, it varies by the facility. There are a lot of different business models. There are a lot of different pricing models. A lot of fast charging units are already using pricing models and are not free anymore. There are still some automaker subsidies that make it free in certain cases, but yeah, we already see that charging facilities are moving away from being free. Out into the future, there's always likely to be some sort of charging facility that is free because it's based on a different business model for attracting customers to sites or what have you. But at least when it comes to DC fast charging and other forms of charging services, we see and are going to continue to see a move away from sort of the energy pricing models that we're familiar with from the gasoline retail fuel model to basically timed charges more so. There's always going to be a little bit of variation in there, but we're seeing that now. We're going to continue to see it in the future.
Great, thank you. I have a question here from Arno Stencil, who says, are EVs really loading overnight or at daytime at work? And at night, could they help feed back into the grid and help stabilize in a limited way so that there's enough energy available in the morning to go to work again? So that's a question we kind of touched on earlier. Anybody, Rick, do you have any thoughts on that?
Well, it's highly dependent on, kind of what type of EV, who's the owner, what's the purpose of the EV. A residential charging, the average person with an EV that might want to charge overnight, especially if they're getting a favorable off-peak charging tariff from their local utility.
Mhm.
That's going to influence things in one direction, whereas some of the fleet operators that we've talked about previously are going to be completely different. I mean, take a public transit authority that runs buses. If they want to convert all those buses from diesel to electric, they don't have they can't just say, well, we're going to charge them at night, because that's not going to work for them. They have to optimize charging around the bus schedules. So it's really going to vary depending on the types of EVs and what they're being used for. And once again, this gets back to, you have to have the capability, you have to have the data to manage the charging regardless of what the pattern is.
Absolutely. On that topic, getting the data, here's a question for you, Siri. The question comes from Phil Wolf, who says, are you getting the data from EVs that we really need for storage, demand, and supply prediction? Is that something that we're currently getting, or do we have to evolve the EV smartness themselves, that aspect of the EVs themselves?
That is a work in progress, because, from a utility perspective, we do have the capability to look at loads. We do have the capability to look at loads in a spatial format, right? So you know exactly where those loads are growing. But that said, the ability to take, what you have today and to be able to project what is going to happen over the next few years and tie that exclusively to EV sort of demand, right? That is difficult to do, because that load could be increasing because of many reasons, right? But to tie it to EV load is difficult. And I say it's difficult because EV load is different from regular load, right? Because there's a coincident load part of it that's very important to know and to be able to manage. Now, that said, the opportunities here are tremendous, right? Right from the smart charging, right? I see that as a huge opportunity, and really the way smart charging should work, the way I envision it is, the smart chargers that are sitting on, say, the electric vehicles should be able to communicate through the grid infrastructure to know when is the cheapest time to actually charge, right? If we can get that sort of smarts in the smart charging, then that will make the charging an extremely beneficial thing from a customer's perspective. This also means that the utilities, the market clearing mechanisms, the smart charging, all of these things need to talk to each other. So it is not a simple problem. It is a complicated problem, but there are lots of opportunities.
Mm-hmm. I had always thought that the EV smart chargers needed a kind of communications infrastructure a little bit like the way MIDI works for musical instrument digital interfacing, where they've adapted MIDI to be a lighting control system and all of this. It seems that its capability is that you can send a whole bunch of different types of messages, status messages of various different types. It's a fairly sophisticated architecture for message transmission. I always thought that the EV infrastructure needed more of that.
I'm sure we could do with all the communication capabilities that basically feed into the tools and available solutions that can manage all of this in a holistic manner.
Absolutely. Well, I certainly thank all of our guests for sending all these great questions. We've covered most of the big topics, I think, here. I have one more here that I think is interesting that I will throw out here before we finish up our session. Just in 1 minute, the question is, would it be realistic to encourage car sharing in public transportation? Could that make a difference to get a more manageable load for EVs? And I think the answer from my perspective is yes, that makes great sense. The idea of electric buses and all of this that can share that load makes sense. Any thoughts from any of our panelists?
I'll go first. Absolutely. I think that's spot on right there. If you can, look, this is a load management problem. So if you can take away some of that load, then from a utility perspective, that's right up there. You know, this
Absolutely.
aligns up with everything that we've been talking about.
Well, that's good. Well, that's all the time we have, folks. So I apologize if we didn't get to your question, but I'd like to wrap up by thanking all of our guests, our attendees, everyone who asked a question, and our great sponsors, Eurotech and Hitachi Vantara. So thanks again to our speakers for their amazing insights and knowledge. Let me tell you a little bit about what's going ahead. We've recorded today's session. If you wish to access the content, I recommend you purchase an annual pass for IIoT World events. This will provide you with access to iiotday.com content and only costs $99.99. Your support ensures that we have all this great content to share. I'd like to thank our attendees for listening in and your questions again. And I remind you that our next session, which is strategies for securing operational technology environments in the energy and utilities sector, is beginning at the top of the hour. And if you prefer not to skip away from this channel, we've got Kevin O'Donovan, who's a trusted technical advisor for IIoT World, will be showing up on this channel right after our session, providing his thoughts and insights on the first 3 sessions today, including this one that we've just had. So thank you to everyone, and I hope you have a great day, and I hope the rest of the conference goes really well. Thanks,
Very
everyone.
good. Thank you.
Thanks,
Appreciate
Graham.
it.
Hey, thank you, Graham. And folks, we're halfway through Energy Day, and just a couple of quick comments from myself. I've been listening in here, and obviously I had the opportunity to moderate the first session. A couple of things have stood out for me, and I'll be sharing this on the LinkedIn event page as well. And obviously everybody else, please feel free to chime in and on the chat. But a couple of things. In the first session this morning, we were talking about digital solutions. And the thing that came out was that a lot of the digital solutions we have today are just the same old technology. We're just finding different ways to use them. But I suppose the other key thing for me was that as cool as all the technology is, it's still about the people and the knowledge that's in people's heads that we still need to be able to use in that context. So people. Second one, in the oil and gas session, it was Danielle from Guidehouse made a great point in that from her perspective in the oil and gas industry, the best implementations of industrial IoT is stuff that's using or taking away mundane work. You know, that's where you get the cost savings. That's where you get the efficiencies. And I'm a technology guy, so drones and robots and all that cool stuff is great, but they're hard. Look at taking out the mundane activities and making them more efficient. And the last one here in Graham's session, two things jumped out to me. It was Scott mentioning about the battery swap model that we see in China, and they expecting to see that coming into Europe and North America. Not for everybody, but keep an eye on that. And it was Rick from Hitachi called out power quality. We need to figure out watch for power quality as we connect up more and more, especially the large vehicle fleets and stuff. So again, there were straight things off top of my head. As Graham just pointed out, the next couple of sessions, we have 2 cybersecurity sessions coming up. There's a session on AI used in energy management software. So, hey, I hope everyone's enjoying it. I've certainly learned a lot, and to Graham and everybody, thanks a lot. And we'll see you at the next couple of sessions.